If you have your third homework and you want to take a picture of it or annotate the answers so you know where I'm going to go over in a second, you can do that. And I'll take it up when you're ready. I'll go over the third homework tonight. And we're going to talk about linear regression tonight and get the correlation tonight.
We're not ready. We don't want no part of this.
We're gonna go over it.
He's gonna
What
take
is
a
it, go ahead
picture.
and keep it while we go over it?
No, take it up.
He said take a
You can
picture.
take a picture of it or note where you want.
Here, you can hand that to me. Okay.
Make sure your name's wrong.
You guys wanna pass it down so you know.
I come around. I'll go around that side.
You come around? Okay.
So those are basically the numbers for x squared. In terms of the first problem, the summation of x I'm doing is 180. You know, those numbers, right? When you square every number and add all those up, you should get 3,370. So the summation of x squared, 3,070, n was equal to 10. If you take the 180 divided by the 10 for the sample, x bar is 18. So those numbers you're starting with. Okay? You go to the second, the S, in this case, standard deviation for the sample, sets up as the equation. Don't forget to square the whole thing. Taking the numbers you just generated here, plug them into the equation, you get 3,370 minus 180 squared over 10 over 9, square the whole thing. All right, so plug it in the summation of x squared, plug it in the summation of x quantity squared. Make sure you set these two up correctly, right? Divided by 9. When you do all the math and calculations of that one, that should turn out to be right at 3.80 for S. Okay?
I did mine a little bit longer.
What do you mean?
I think,
Maybe if you run out the math of that, that's
yeah,
fine.
okay.
Yeah, I'm just shorthanding here just to.
Yeah.
I'm not, well, I do not need to at this point go over every single step. But
Yeah.
That's just at this point doing the math.
Okay, because I did a lot of math on that part.
And that,
On the
I
last
recommend
part.
that when you're doing it, draw out all the math, show me every step so I know what you
Okay.
did, how you got the numbers, and that way if you get a number that's different from the 3.8, I can check back through your math and figure out where you made the
Well,
mistake.
there is a lot of math to that part, isn't there?
This number basically comes 3,370 minus 3,240 divided by 9. So that takes the 180, squares it, divided by 10. So the 180 squared will be 3,240 divided by 10, 3,240, which gives you then 130 divided by 9, which gives you 14.44. Square that, which gives you the 3.8. That's the steps to get there.
I did a lot more than that.
You
There's
did
really
the
only one
square
step that's skipped there,
every
and
one.
that's this one.
Yeah, I did a lot more than that.
I did too, and now
I
you
did a
wasted.
lot more than that. Like, I
That's the order you would do it through. I skipped one
I don't
step
know why
here,
I-
squaring that number divided by 10.
I mean, I think I have a learning disability or something. Because I literally,
Honey, I was doing extra. I was like, okay, this has got to be right. Like, I literally.
I can't speak to that.
Okay.
Bottom of the page.
Okay.
Calculating z-scores, right? There are two ways to calculate the z-score, one of which is much faster and much more efficient. If you have x bar minus, oh sorry, I'll go the other way. It doesn't matter if you want to keep your z-score safe. We'll say x minus x bar divided by s, or you could have done x minus x bar divided by summation of x minus summation of x, quantity squared over n minus 1. Those two formulas are equivalent, but you've already taken this part of the formula and done it here.
Because that's the mean, right? The over top of the x. The other one.
Yes.
Yes.
This is the mean of the sample, yes.
Yes.
X bar is mean of the sample.
Yes. Okay. Thank you. I
Right.
just want to make sure.
This version of the equation is simplest once you got this number. Because the numbers here on the bottom left, these are x's. So the first one is 21.8 minus the mean is 18, right? Divided by the 3.8, which gives you 3.8 over 3.8, which is 1. You want 1.0. Quick note, don't know how many of you did this, but you make sure you have the n minus 1 here, which gives you this value. You do not need to go back and recalculate this as if it's population data, right? So, well, if you have the n, if you have 10 in the denominator here, you've got a number slightly smaller than 3.8, like 3.78 or 3.79 somewhere. When it's slightly smaller than this, you get slightly different calculation. This is just a hair off.
So it only has to be the other.
You're using sample data here.
Sample data.
Notice the question where assumed data above is sample data, so it is separate, but when I say it's representative of population data, by saying it's representative of, that means you can use the normal distribution to calculate it.
Gotcha.
Right? You don't have to have.
But you don't have to have the
population
other answer.
data. Right, you don't have to have the
Okay.
calculations. You're gonna calculate it straight through the sample. So if I have 11 minus 18 over 3.8, that gives me a negative 1.84. The 15 minus the 18 over the 3.8 gives me a z-score of negative 0.79. And the last one was 25 minus the 18 over the 3.8, which gives me a z-score of 1.84 above. This was 1.84 below, 1.84 above, positive.
Okay.
These are the values. You then go to the second page, find the areas and percentages with. Right? So you're starting off with raw data over here, calculating standard deviation. Using the standard deviation, calculate a z-score, right? Getting z-scores for the ones asked for. Now we're going to go from the z-scores to the percentages, right? So I'm going to get rid of the raw data over here, so I don't need it anymore.
Okay, I have a question real quick. Okay, so if we did this homework today, are we gonna have a grade for it like soon? Because I wanna know if I got my answers right, that way I can know I'm studying correctly. Because if I don't have my answers right, I don't know I'm studying correctly.
I will try to get them in hopefully tomorrow.
You see what I'm saying?
If-
Yes,
yeah.
because the sooner I have
will
it,
try to
I
get them
know.
myself tomorrow.
Okay, so, but how are you going to do, I mean, like, because we're not gonna have the paper back until next week.
Right, I will give back this homework next week.
Yeah.
I will take up and go over the fourth homework I'm
Okay.
going to give out tonight.
Okay, so you're gonna
Not
try to
next week,
post
2
our,
weeks.
okay,
Yes.
so you're gonna try to post our stuff tonight,
Yes.
tomorrow.
Yes.
And
For the
that
third
way,
homework.
well, because I can come to the office, or someone can come to the office and say, hey, which problems did I miss?
Right.
That way they get to study ahead, because if I don't know
Actually-
which problems if I don't know that I'm doing it right, then,
But the post of the grades doesn't tell you which grades.
yeah,
you
it don't
missed.
tell me which ones I
So,
missed.
Right.
So I'm gonna need to obviously go by your office.
If you missed any,
If I missed it, you're correct.
I think you'll be all right.
Okay.
All right, so following question is assume normal distribution. You want to draw it? Notice the mean is 18. Notice that's going to be a raw score. Mean of the z-score is 0. Right? Typically, you're going to want two number rows across the bottom here. You want the mean for the raw scores. You want the mean for the z-scores. Mean for the z-scores will always be 0. Okay? And you want to essentially draw the appropriate area and find the percentage. For the first one, what is population that falls below a score value of 15? The 15 must fall to the left of the 18. You want the region below, so there. You've already done the 15 over here, okay, the last number. Gave you a z-score of negative 0.79, so there's a negative 0.79 there. You go to your z-table, look up at 0.79. This is the B column, sorry, this is the B column, this is the C column. column you're interested in is 0.2148, right? Which means this area that you're not interested in as particularly is 2852, but that's the correct answer. So 2148 is the correct answer. All right, just looking up the 0.79.
Like, I literally, on that, like, cause we were looking at it, come back over here to this thing.
This comes straight from the table.
Yeah, so, cause I was getting confused with the area between that, but the area beyond.
Look in the bottom right-hand corner, it tells you which area is the shaded area between and the area beyond.
Oh, thank you. I was so confused.
That's the little diagram in the corner is supposed to help you.
Okay, gotcha. So that is whenever it asks for the Z, that's that area.
The line vertically, that is
Okay.
not the mean,
Gotcha.
that's your Z-score.
Okay.
That's this line in this case right here, it's 15, which corresponds to the 0.79. It's negative, table's symmetrical, right? So you
Gotcha.
look up the positive 0.79.
Okay.
You want the area outside, right, which is the C column,
Mm-hmm.
in this case 2148.
Okay, got you.
Again, in this one, what's the percentage of the population that falls below a score of 21.8? The 21.8 falls to the right of the 18, it's gonna be up here somewhere. We calculated the 21.0 there for the Z-score. The Z-score associated with that is 1.0. This area then becomes 0.3413, but I want this area, so below the 21, which is going to include everything left of it as well. So the 3413 plus the 50%, correct answer is 0.8413. Make sense?
I did it a different way.
If you took the 0.3413 and used the C column and subtracted the C column from 1,
Yeah.
that's perfectly fine. You'll still get the right answer,
Okay.
That's what I did too.
right? As long as you recognize this whole curve is equal to 1, area under the curve.
Okay.
If you looked up this area right here and subtracted it from 1, you'll still get the same answer, right? Because you're going to have essentially the point, well, you have 1 minus 0.1587. You still get the right number. Is that all right? All right, so the third one. I'll put it a little smaller. Mean of 18, Z-score 0. You want to know what's the percentage of the population that falls between score values of 15 and 25? Right?
Let's see if I did this one.
We already looked at 15, that's the minus 0.79 here. On this problem, we did lower than. Now we want this area, essentially between these two scores, right? We said from the previous calculation that this area is 0.2852, right? That's the area between the score and the mean for the 15 up to 18. You go to 25. 25 gives me a Z-score here of 1.84, right? I want the B column associated with that one between the mean and that score. So the B column there comes in this one is 0.4671. I take these two numbers, add them together. The correct answer then turns out to be 0.7523 when you add those two values together. So 75.23% of the data. Does that make sense?
It's getting there.
Basic idea is you're trying to calculate
Mhm.
above, below, between.
Okay.
Depending upon where your Z-score falls, right, which is going to be your calculation you're going to use using the Z-score equation, right? You're going to look it up in the table. You're going to use whatever makes sense to you with regard to the B column or the C column. Do you want to use the area between the middle, the mean, and the score you're looking at? Or do you want to use the area from the score outside the area you're looking at? So for example, I said, what is the percentage of scores which falls below a 15 or higher than a 25? Right? How'd you get that number? So what's the percentage of the curve which falls below a 15 or higher than a 25? Just did it a minute ago.
Me?
So,
That value,
You add it
subtract
together.
it from 1,
Yeah.
right? So 2477. 2477. 2477. Right? Because that would be, well, shading it, that would be this area. Less than 15, higher than 25. Calculate between is a 75. everything outside must be 1 minus that. That make sense?
So
Yeah.
what if you got like, oh my,
You have a question?
nah, it doesn't matter.
Might matter if you're worried.
Not so like,
Alright,
I messed around and flipped my numbers. I got dyscalculated, so I flipped my numbers sometimes. I did the process the same way you did, but I'm a number off because alright. Yeah.
okay. So the extra credit. Before doing extra credit, keep in mind,
Okay.
the entire process here is you take a score value, convert it to a z-score, convert that to a percentage proportion out of 1, right? You're given a raw score, you can calculate a standard deviation score, or z-score, and take that, look it up in the table, get a percentage, right? So it's basically starting with, starting the raw score x, calculate a z-score, right? Use that z-score, look it up, calculate a percentage, right? The extra credit is, here's a percentage, right? Get a z-score associated with the percentage, calculate a raw score, right? So the extra credit is going to work this equation backwards, right? It's still solving for a single unknown at any given time. So the first thing it starts off with, the best way to do this is draw it so you know what you're dealing with. Curve. I'm going to turn it in, you're going to look at stuff first.
I'm not changing anything.
Okay.
But I
I'll
was
take
just
your word
trying
for it.
to, okay,
Hey, you're all the way on the extra credit anyway.
maybe I should go ahead and, I'm not changing anything, that don't mean I won't write anything in a blank spot. I barely got through the other questions, I'd be damned if I do that extra credit.
I know, but I didn't even try.
Did anybody try?
I drew the
It's
picture.
worth going over. It's worth understanding the concept.
I don't know if it's right or not, but I attempted to.
Okay. Attempts to make it partial credit.
Okay.
Alright, using the same z-scores, using the same sample, using the same type of interpretations. Right? What are the two score values that you would have with 80% of the population in the middle of the distribution, right? Basically around the mean. And I assume it's evenly distributed. You could have, for example, if I say 80%, I might have 45% here, 35% here, I might have 25% here, and 55% there. Right? But the way it kind of works out, you want evenly in the middle, right? Which means this area is 0.4000, and this area is supposed to be 0.4000, right? Those two added together will give you 80% in the middle, right? The question becomes, what is that value? Those values, those two values. So it really only one value, one's positive, one's negative, because it's above and below. Okay?
Yeah, it is 90.
Well, I got 80. I may have pulled the wrong homework. Yep, yours says 90. That's okay. We'll use 90. I don't have the exact number, but I'll have the table. Sorry, I pulled the wrong key homework. All my other numbers you should pull correct. It says 45%. Right? Make that a 90. Right, so 90% in the middle. Right? So you go to your table, right? Notice this transition, if you have a z-score going to percentage, goes to your table. This one, I'll put it in your formula, goes from the formula, right? You can use a percentage, look it up, find a z, use the z-score, use the formula to calculate x. Right?
What's the formula again?
This one over here. That formula for the z-score. Right?
Yeah, but you know what though?
I'll show it to you in a second. Right? It'll make sense.
Yeah.
All right, so going to a 0.45, you have a little difficulty here. Notice if I'm looking at this area for the 0.45, that's the B column in the table, right? If you go down the B column until you hit a 0.45, right? The B column of the 0.45 should give you a value of, if I can find one here. Oh, there it is. Two choices, right? There is a 0.4495, and there's a 0.4505, right? In other words, I'll write this way, I'm gonna write one on one side, one on the other side. Let me try to exaggerate this. There's one score there, and there's one score there. This one is 0.4495. This one is 0.4505, right? Which corresponds to those choices. The 0.45 is halfway between those two scores, right? Don't you remember in the first week of class we talked about interpolation? You didn't have to interpolate here. I'm going to recommend you don't interpolate here. If you interpolated and you realize that's exactly halfway, you could use a value of 0.4400. Sorry, 0.445. So it's 0.4500, which is halfway between the 0.5 and the 9.5. It's not a good way to do it. Better way to do it is to recognize I want here between these 2 points. If I want to guarantee I'm between those 2 points, which value do I want to use? Huh?
The one that way, right?
Well, the one that way and the one this way. Direction matters. It's on which side, right?
Above, below, in between.
You want that one,
Okay.
right? If you choose the 0.4495, you don't have 95% of the data. You got 94.99% of the data, right? You want to definitely include this 90%, right? You want to be outside that region, so you make sure you get everything inside it, right? If you choose this one, the smaller one, you're missing this little area right here, and you're missing this little area right here, right? So you're going to err on the conservative side and choose the one that's slightly larger. If you look up, I was going to say 4505, so 0.4505 there, and this is a negative 0.4505 because it's symmetrical. Those are your z-scores, right? Now when you go from the z-score to the x value, using my z-score equation, z is now 0.4505. We just look that up in the table, right? The mean is 18. Standard deviation is still 3.8. Solve for x. One unknown, 3 knowns. Okay? So remember how to do that?
Okay, so for the z, so it's not the 1.65 where b is equal to 0.4.
Oh, I'm sorry, you're right, yes. Sorry. My apologies, I'm doing the same mistake a lot of times. 1.65, negative. Sorry, you are correct. I'm not in my head.
No, you're okay. I was like, oh my gosh. I was like,
No, you're good.
I
You're
really
good.
don't
You
know
made a
what's
very
going
good
on.
point there. The 0.4505 is a percentage. That corresponds to a z-score of 1.65, which is here. So I'm going to use the positive value, 1.65. Now solve for x, right? So basically multiply each side of the equation by 3.8, right? And then add 18 to each side of the equation. In that case, x is going to be equal to, oops, over here. Actually, I didn't bring a calculator. I did not bring my calculator. So.
You can use mine if you get extra, so I get the points. You can use it.
That's okay. I don't want to be in there.
At least 1 point, I don't know.
There's a lot of stuff on it.
Have you ever done a keyboard like
Got a lot of buttons on this calculator. That's cool.
Get you a keyboard like that, honey.
Oh, it does, wow.
Yeah. Some math professor.
I'm done.
He likes being insulted. Thank you. We gotta laugh to keep from crying or dying.
334.27 height. The value there is basically x minus, well, the x is going to be 6.24 above and below the mean. Right? And so above the mean is 24, below the mean is going to be 11.73. So the low value, this one, is 11.73. This one's 24.27. One below, one above the mean. Which is your x score here? You have a question about?
Yeah, I don't know, I just took a different, I got the same answers, but instead of like using, I guess I just simplified that, because I just did the mean plus the z-score times the standard deviation. instead of like writing it out like that and solving for x?
You are effectively solving for x, but
Yeah.
you're rearranging the equation
I
prior to
guess.
solving it,
Yeah.
right? You
Exactly. Is
you
it
take-
okay? Is it okay, or do I have
Yeah,
to,
it's
like,
fine.
if I'm writing
It's
it
fine.
out? Like,
There are actually two ways to do this in terms of math. You can either start with the equation the way I've got it set up here, right, and then work the algebraic manipulation to solve for x. Or you can solve for x on the terms and then put the numbers in, right? Either way works. That's fine. Is that okay? The main take home for the extra credit, if you don't quite get it, it's okay. I'm not going to ask you a question like this on a test. The main point is the numbers are essentially interchangeable, they are reversible. If you know a raw score, you can calculate a z-score. If you calculate a z-score, you can look it up and find a percentage. If you're given a percentage, you can use a table to look up a z-score, take that z-score, calculate a raw score. These are all go back and forth, right? If you know one, you know all three, right? So if you're given one, you can find any of the three. All right? All right, so last, any questions on the z-scores for you for now? Last class, we were talking about linear regression. Before I go into linear regression tonight, I'm going to mention a couple things. Our next class will be our second test. The next class is our second test. But it's not next week. It's 2 weeks because next week is spring break.
Hallelujah.
Can you please, like, go over all of this again?
Not like go over it.
I get the formula for z-scores. That's pretty simple. X minus
It's one of the smaller
mean.
formulas. It's one of the more
So I
straightforward.
get that.
I think.
I don't get the
word.
graphing. Okay.
Okay.
I don't get the graphs. I don't get this table. I don't get nothing. I'm not gonna lie. So if you got time today, please could you
So
kinda
what
give
we
us a
did-
refresher?
So what we did for our homework this time around is gonna be on that
Test.
test.
Yes.
And tonight's homework.
And tonight's going to be on test, yes.
Got you.
Okay.
And that's it?
Yeah, unfortunately, because we missed 2 days.
So just yesterday, just last week's
And there are
homework?
going to be 2 big formulas tonight. Well, 2 big formulas nested in smaller formulas. But,
Sounds great.
Okay.
And that's gonna be on the test too?
yes.
Make it slightly easy because.
Yes. If you,
Look out for us because
I'm trying.
I know.
We'll have this.
Honey,
Because I've
every
gotta
one of
get-
us have gotta have this class. We've gotta have it. It's not
Because I
like-
have to get through a certain amount of material before the second test, I'm losing some information from tonight. So tonight's going to simplify a couple things. I'm not going to give you a couple of bits
Got
I'd
you.
otherwise give you.
Okay.
So I'm cutting the linear regression stuff in half.
Thank you
Thank you.
so much.
Oh,
Praise you.
You're thanking me now. Wait
Yes,
till later.
praise-
You do the question.
Praise you.
He gave us this instead.
But we'll be able to have this for the
Yes,
test.
bring your tables with you. If you don't have a table, I will bring extras.
Okay.
so yeah, if you could give me a refresher, and hopefully I can catch on this time. But
No, you got
for some
this.
reason, I just don't even, I don't get it. That's the only part I get, the formula.
You got it.
See if y'all actually had y'all study group, you could have watched the video again and get what you know.
We gonna have it over there, especially this part, see what
Yeah,
time
see
you
it
on.
going.
Okay,
So there's our 2 formulas.
okay.
Top formulas, 2 formulas. One's the simple version. One's the expanded formula, given S is equal to all the stuff in the denominator here.
Right,
Top formula is for a standard deviation, or I should take that back. Top formula denominator is for a standard deviation. That standard deviation is a sample standard deviation. The
Mhm.
bottom formula uses the standard deviation from a population, which means n instead of n minus 1.
right.
Okay? Like I had a second ago.
So the top is the sample and the bottom is the population.
Yep.
Correct.
That's the
If you're given population data, you use the bottom formula. If you're given sample data, you use the top formula.
sample. Got you.
If you are simply given the raw score, the standard deviation, right, and the mean, you can plug them straight into these 3 locations, right? So last class I was talking things like the street and how many houses up down the street kind of thing. Let's do a different example. Suppose I look at the classrooms around campus here, right? And just look at this classroom. Suppose the average number of chairs in a classroom is 32. All right? Right now in the classroom there are 32 chairs minus that one, not counting that one, in the desks. Right? Not every classroom is gonna have the same number of chairs. Chairs get moved around. Some chairs may have 28. Some classrooms may have 28 chairs. Some classrooms may have more, right? Let's say there's a variability in the number of chairs in a given classroom, right? And I'm just gonna give you a number here. Say, assume this sample classrooms that the variability is 4 chairs. So the standard deviation is 4, right?
On the test, will you give us a standard deviation or will we have to calculate it?
I'll probably do both,
Okay.
right? I'm doing it here initially, so
Okay.
I'm gonna walk through it.
Yeah.
Simple version first.
Right.
Right? All right, so give it a mean, give it a standard deviation. Right? I asked you, what is the probability of randomly selecting, well, take one step back. Assume the number of chairs in a classroom is normally distributed. Right? Making that statement, I'm not gonna use my z-scores. Right? So assume the number of chairs in a classroom is normally distributed. What is the probability of randomly finding a classroom with 36 or more chairs? So here I'm asked for some probability. Okay? Notice, you got 3 numbers. Right? I just gave you 3 numbers. Okay? And coincidentally enough, there are exactly 3 numbers in this formula. Technically 4, but you're gonna have 3, solve for 1. Right? The hardest part of this is knowing which one's the mean, which one's the raw score, and which one is S. Right? But I told you right here, that's the mean, that's S, that's the raw score. Right? So they plug them into the formula, Z equals 36 minus the 32 over 4. Okay? Do the math on that, it's very simple. You get a z-score equal to 1.0. Right? Not all of your z-scores will be 1.0, but it's a nice example because you get numbers that are pretty well known repetitively. Draw the distribution. I will ask you on the exam, draw the distribution. Oops.
Right.
I asked for this area, 36 or more. Right?
So
You're given a score here,
right,
X.
right,
You just calculated a Z, that's 1.
right.
So here's 36, there's 1. Question is, what is the percentage? This comes from the formula. You're going back and forth between raw scores and z-scores. This comes from the table. So going from a z-score to the table, right? You're essentially asking, what is that area? Right? So what's that area? We've already had it a couple times, that particular one.
And that's when we go to the table and find the 1.00 and get the C is 0.1587.
Yep. That's 1587.
Okay. I feel like I just forgot. That's what happened.
But you remember now.
Yeah.
If I ask the same kind of question, right? Assume 32 classrooms, 32 chairs per classroom on average. What is the number of chairs? Sorry, what is the percentage you would expect to find that have 40 or more chairs in the classroom? Assume it's normally distributed. What is the probability of finding a classroom with 40 or more chairs? The only thing it changes is this. Right? Changes to this. Right? So instead of
Question
having
though, so, okay, 2 standard deviations over.
2 standard deviations above the mean, in this case, well, you're looking for above 2 standard deviations above the mean. And in this case, C column, let me try and find it real quick right on here. Find it?
So then it'll just be the 40 minus 32?
40
Divided
minus
by
32 divided by 4,
2.
which is equal to 8 in the numerator, divided by 4, 2.
So then you find the 2.00 thingy and get yep.
0228.
So and you gave us a clear example. So, but, okay, so the C column, the
C column is anywhere from this location
yes.
out.
And then the B column is anywhere from the middle out.
From the mean out to the point you're talking about.
It's the B's for between.
Right,
If you wanna think B is between there, that's fine, but in the table it's A, B, C, so it doesn't have between, that works.
What's the 939?
That works.
so if you ask
If
us
that works,
anything,
then you mind, that's good.
so if you ask us anything between, we would be looking at the B column.
What is the percentage of classrooms that would have between 32 and 36 chairs in them?
That's a good question, we should do that one. I got it on the homework somehow, well, no, I don't know, cause I wasn't. I had to do it on the homework, I should say.
This was another easy one.
Perfect.
So you're fine.
Because 32 is the mean, you don't do that, you only calculate that one.
Exactly, cause we just.
You've already
did.
calculated the 36.
Right,
36 was there, that was 1. So really you're asking for this area. Right?
let me catch up.
Which is 3, 4, 1, 3. Right?
What did you just do? He
Found the Z
I
score.
looked down for 1 second,
He found the Z score and said we're going to be 0.34.
so he found the B score of 1.0, the Z score.
Yeah,
I'm
he-
like the B score.
Yeah,
Right,
yeah,
right.
yeah.
The original question, what percent between 32 and 36? 32 is the middle,
Right,
right? 36 we already calculated had a z-score of 1. Right? Previously asked, what is the percentage of classrooms that have more than 36? That was the C column. Now I'm saying, what is the percentage of classes that have between the mean and that number? That's the B column. When you look it up, with a z-score of 1, you should have 0.3413.
right, okay, so for some reason I thought since you were asking like 2 between, we had to like do like a whole bunch of other.
Let's do a whole bunch.
Okay.
What percentage of classrooms have between, let's say, 34 and 36 chairs in them? What percentage of classrooms have between 34 and 36 chairs in them?
Let me write.
Always draw these. Drawing these will tend to make them make sense, right? Because look at the problem, you go, what the hell is that, right? Draw them, and it should make sense once you place things where they need to be, so that you can figure things out, right? So we just said the mean's equal to 32. We've already done the 36 there had a z-score of 1, right? Z-score of the 32 is 0, okay? Now I'm saying, what is the probability between 34 and 36? I have not done 34 yet. The 34 is going to fall halfway between the 32 and the 36, so I want that mark, and then I want between those two scores. Right? So area between those regions. Okay? In order to calculate a z-score for the 34, I have to use the equation. 34 minus 32 divided by the 4, which gives me a z-score of 0.5. Right, so it'll be a z-score of 0.5. Question now is, what area do you want to use to calculate the one in the middle?
It would be B, because you asked
Do you want to use the
me.
B column? You don't have to use the B column. Do you want to use the B column?
And we don't have to because,
Let's do the B column. We'll see.
okay,
What's the B column associated with the 34 associated with the z-score of 0.5? This area, right?
0.1915.
Right,
Okay.
right? What is the B column associated with the 1? We've already done it a couple times.
that 0.1587,
No.
no. Oh,
Yeah.
0.3413, B.
If the bigger area, this area, is 3413, and the smaller area is 1915, how do you get this area? Subtract the smaller from the bigger one, right? Take the 1915, subtract that from 3413, right? And you'll probably get 1308? Is that right?
No.
Subtract those numbers. Sorry, 1508. Is that right?
Oh, I did it wrong. No, that's not right.
Huh?
I
Did I miss my number somewhere? I'm doing it in my head, so I'm probably off somewhere.
0.1498.
That works. And that corresponds to this area. Right? If you wanted to use the C column, I'm gonna redraw it so it'll look similar, but maybe not be quite as cluttered. There's 32, there's 34, there's 36, 0.51. This area is 1587, right? This area is 0.5 minus 1915, all right? It's gonna be 0.2085. Right? No, it's not right there. 3085. Double check my math. What's 0.5 minus 1915? On the table in front of you.
You said 0.5 minus what?
0.5 minus this number. 1915.
0.3085.
Yep, okay. Now I got this number and this number. If I want to find this area, I can subtract the small one from the bigger one, and I'll get the one for 980. Again, the exact same value. Right? Does that make sense? I don't care if you use the B column or the C column. I don't care if you use some combination, as long as you do it correctly, logically correct. So you have the B column from the small one, the inner one, plus the C column from the outer one. Add them together, subtract them from 0.5. That works too. Right? So I can take this area plus this area, add them together, and subtract them from the overall 0.5, and I'll still get the same number. Is that okay? You have to calculate above, below, between. Right? Just like I did before, it's now using a table where you're converting raw score to z-score to percentage, right? Sometimes multiple times, you have two z-scores. If they're on the same side of the mean, you'll have to subtract the bigger one, take away the smaller one. If they're on opposite sides of the mean, if you're looking between the scores, you're adding them together, right? Or if you're looking outside the scores, you're taking the C columns and adding them together. Basically, it's manipulating areas.
And how would you grade on the exam if we get that part right, but the stuff's a little wonky on the normal distribution graph? Like
If you get the right, if you're calculating a z-score from raw scores, if you give me the right equation, right, I'll give you half credit for it. You won't worth more than 4 or 5 points, 6 points maybe. But if you give me the right equation, I'll give you half points for it, depending on how many points you didn't miss, based on how many numbers you get messed up, right? If you put in a mean instead of an S, or put in an S instead of a mean kind of stuff, there you'll miss points for every mistake you make in the equation. But a lot of the numbers, the final kind of questions are simply looking up on the table, right? It's really, well, there's no way to give partial credit if you give me the wrong number, either without knowing how to look it up, or give me a number that's wrong looking it up, right? Just looking up the table, you're pulling a number straight off the table, right? And there's no math there. Basically, here's my z-score, look it up, here's the answer in terms of the probability.
Okay.
Okay. Now you extend this. Over here, I gave you, said here's the mean, here's standard deviation. Right? On the homework, and you may see this on the exam, I'll say here's a set of sample scores, right? Calculate the standard deviation for it. Use that standard deviation to calculate z-scores. So you may get this version of the equation. Right? We have to plug in all these values, calculating all the squared scores to get a standard deviation.
Mm-hmm.
Right? That's much like the first page of the homework. Then once you get the standardization, you're jumping to this kind of concept. All right? I don't want to belabor this too much because we have a lot of stuff to do tonight.
That's understood.
All right, so tonight we're talking about linear regressions. Stuff. Textbook will use a line equation like that. Y equals bx plus a. The b in the equation, as we pointed out last class, in this case b sub y, but the b here is the slope. The a sub y, is the y-intercept. Right? The way you traditionally calculate these types of things, high school and middle school and so on, when you're calculating lines, you can essentially use paired scores in your Cartesian planes. And essentially take, for example, a slope, something like y sub 2 minus y sub 1 over x 2 minus x sub 1. And the slope we basically calculate as rise over run. It's sometimes listed as delta y over delta x, right? You could use any two paired sets of scores, assuming, big assumption, every score falls on the same straight line, right, to calculate any given line. Once you have the slope, you take any two paired values for x and y, you can plug them in, solve for the intercept, and get the intercept term. Right? So once you have this value, if you take any two paired x and y scores, you can plug in y, you can plug in the slope you calculated, you can plug in x, and solve for the intercept. All right? Still solving for a single unknown. What we're going to go into, slightly more involved, we're going to go into essentially calculating the line of best fit for scatter plots. Okay. Last week when I showed you a graph, it kind of looked like, let's say, something like this. Right? Conceptually, there's a single straight line that fits that data the best. Right? And visually, that line is probably pretty close to the way I drew it. Mathematically, there is a perfect straight line that fits that graph. And the way you calculate that is conceptually, right? The formula is going to be a little different. Conceptually, I calculate what are the distances between each point and that line, that imaginary line I want to get. I add up all those distances, right? Average by the number of distances I take and minimize it. Make it as small as possible, right? Essentially, this is, I'll go and give you a takeaway. It's kind of like doing a standard deviation, where the standard deviation is the minimization of the differences away from the mean, right? Well, if I should say, the summation of x minus the mean is equal to 0. The summation of x minus the mean squared, right, is going to give you a minimum value, right? This is calculating a slope for the minimum value of deviations, right? But instead of being a single point like an average, it's spreading out that single point as a line across the x-axis. All right? Don't freak out initially. Slope is going to be this equation. This equation will do what I just described. Right? This is simple. This is if all the points are exactly on a straight line. Right?
Will
We're not going to have that.
No.
We're not going to have that at all. I'm not going to do that at all.
Oh,
We're going to do this. It's still an equation for a line. Right? So the equation overall is going to look like this type of equation. Still an equation for a line. Slope, intercept. Right? The b is the slope from over here. Slope looks like that. That will in part look similar to some things we've already had, but also look different from what we've already had. before, when we were calculating standard deviation, if it was for a sample, we had that, right? If you look at the numerator of the standard deviation, this thing, so I'll put it in parentheses there, that's called sum of squares. That piece of the equation shows up here. It's the exact same thing we've already done. Right? Exact same formula. Right? The numerator is essentially going to do the same thing mathematically, but instead of having x squared, I'm going to have an x times y. Because now I've got two sets of paired scores. Right? I've got a series of x values, a series of y values. Right? I've got some coordinate system where I've got x on the horizontal axis and y on the vertical axis. Right? Any single point anywhere in that graph is going to have some x value and some y value associated with it. Right? The numerator here is going to try to converge, well, all those variant terms, the deviations, into a single term. Right? Quick thing to point out, there's no radical sign over there. Right? Standard deviation has a radical sign. That has no radical sign. Right? Likewise, this has divided by n minus 1. There's no divided by n minus 1 over there, either in the numerator or the denominator. Right? Make sense? So do some paired terms here. Assume all of you are going to be our original data points. So is that? I'm trying to think of something that's actually related to give us a decent slope.
What are you trying to figure out?
I'm just going to get some data. I'm thinking some various variables in my head. I'm going to ask you for numbers.
Gotcha.
How many pounds we've lost since taking this class? Burning.
From stress.
I need two sets of numbers.
And how many times we've cried because of this class?
Have you cried?
No.
No,
I
It's
haven't.
really good for
Well,
you.
I asked that because I have my reason.
And if we have,
Yeah.
Then I have to address that with someone else in my life.
I know you got a group chat, ha, make them.
So,
No.
so what you're basically saying is you make
frequently
people
get asked the
cry?
question,
No.
have you made any students cry?
See, yeah.
I get asked that question a lot.
Yeah.
Last semester you did, this semester maybe about 2 times, and we've only had you about 4 times, so yeah, have all the way home, I take the long
I am
way.
frequently asked, have I made any students
Tell them I
cry?
take the long way and just put it on emotional, sad instrumentals.
I'm not surprised.
You just don't care.
You just and he's just so blunt.
He
don't
She said you're a butt.
No, I did not. I said you're blunt. Oh.
Blunt.
He's like, they're talking about me like I'm not here.
I'm going to move some stuff. Let's do this. This will work.
Okay.
Some of you live nearby, E-Town, some of you live further out, so forth. Give or take, if you want to round to there's 5, you don't know the exact value, it's fine. But give or take, how many miles away from campus do you live? How many miles? Yeah,
Yeah.
okay.
1.
So we're going to say X is miles away. Okay?
Okay.
Y is going to be, how long did it take you to drive to get here?
Okay.
Okay? Which is going to be related, right? Presumably, the further away you are, the longer it'll take you to get here. It won't be perfect, right? It's not like you're going to drive 60 miles an hour with no traffic lights every time, so you've got a different number. And probably the length of time in minutes, say in minutes, will be higher than the number of miles till you get here, right? So Y here is going to be time of arrival, right? So I'm going to get some numbers.
40 miles in about 45 minutes. About 15 miles, maybe 20 minutes. Same as her. No, the first one.
Oh.
40 and 45. I don't know, it took me 15 minutes.
3 miles, 5 minutes.
8 miles, 15 minutes.
Yeah, about the same, 7, 15. I'm a real slow driver.
That's okay.
15, 20.
17, 20.
6 and 12.
8 and 19.
70, 65.
10
and 17.
You got plenty of time to cry.
All right. At this point, from this point going forward,
Should we also write this down?
yeah, write these down. This is my data set I'm gonna start using for calculations here in a second.
Okay.
This is, I'm going to use this data set, say for the rest of the evening, although the data sets may change certainly for the exam. The concepts behind linear regression and the concepts behind correlation coefficients are going to rely on similar calculations. There'll be different formulas, but there are similar calculations. Okay? So I'm going to start using the same kind of thing. Whenever you're given at this point a series of x values and a series of y values, you are going to want to create a set of tabular data. Right? Now a series of other columns. Right? At a minimum here, let me get rid of this. And get rid of this, don't need it now. You're going to want a bunch of x squared terms. Whenever you are given a set of raw scores, get into the habit of simply squaring every one of them. Right? So square all your x terms.
So it's he's so small, he should live on.
It should be there. Let's feel your square terms. Okay. You're going to need a set of y squared terms.
Okay.
Get in the habit of squaring all your y terms. Keep your y column and your x column separate from each other so you know which one's which. Squaring your y column. Should give you those values. So I see what I did there.
You just squared both
I
sides.
just squared each column, put two in a column.
Quick.
Sometimes those columns will be next to each other, so the x will be next to the x squared, and the y will be next to the y squared. In this case, I just went x, y, x squared, y squared. The order of the columns is irrelevant. Okay? For all those columns, for all that data, you are going to want the sum of those columns.
Hey.
Right? So you're going to want summation of x. Right? Check my math.
Yes,
You
that's
were
right.
right.
You're AI.
Do I?
You're AI.
Thank you.
He's a robot.
Yes.
That explains. Exactly.
Oh,
394.
I forgot we were supposed to be doing all of them.
You get summation y is 394. Done.
294. Yeah.
294.
Okay.
Yeah, I'm not gonna do those in my head.
That probably hurt.
You will want the sums for them. I got more than that.
What is it? What'd you say?
9,161.
That's what I got.
Another what?
And 9130.
91. Oh, I got 9161.
I got 9161 as well. How much?
We'll see 9161. If there are any mistakes, right, they sometimes show up in the final answer, and you can sometimes tell where your mistake is based on the range in which the answer comes back as being out of the ballpark. Right? So I expect the other number is going to be comparable to that, but probably a little bit lower. Actually, probably a little higher. A little higher than that, though. I didn't bring my little calculator with me, so.
You know what to do if you need a calculator.
8808.
I
That
got
can't be
more than
right.
that.
That can't be
Oh,
right. 8808 cannot be right.
Oh, there's, yeah,
That sounds better.
yeah. I
10,300
did not
what?
include in all the numbers.
10,300 what?
Hmm?
10,300 what?
383.
I got 10,608.
That's
I
what
got
got.
About 14,000. I think.
10,600 what?
10,608.
Alright, so I'll put in summation of x squared, summation of y squared. Now you're gonna need the fun column. Right, this is the one you gotta watch. Column's gonna be xy. Notice the xy term is gonna show up here. Right? Oops. I'll check something real quick. In my head, my formula's looking strange. Oh, that's why. Okay. Duh. That's why it's strange. Take it up. It's still strange in my head. Ah, that's why. Duh. Sometimes I'm. Don't ever trust your brain.
That's why we cry.
There we go. That looks better. I had the wrong formula.
It's okay, you're human.
No, he's not.
He's a robot.
Allegedly.
Exactly. No, he's not.
Allegedly.
Don't insult humans.
I was gonna flip that, but that's okay.
Oh, that's good. Don't insult me.
I, for one, am looking forward to our AI overlords.
Yeah, y'all gonna be the best of friends.
Well, I'm being recorded now, the AI's watching it.
Not gonna be able to see anything, just a blur.
Alright. XY is gonna be the value you're gonna have in here.
So this is the formula.
This whole formula over here is the sum, is the slope formula for the line of best fit. Alright. In order to calculate the formula, we're gonna need a summation of xy, which is this column. So we're gonna come down to the bottom. We're gonna have a summation of xy. The xy term is essentially the paired scores, x and y, times each other. So the first paired score, right, is gonna be 1800.
Uh-huh.
Yep, yep. 300. 1800 again. 15.
Yep.
120. 105. 300. Yep, 105, 300, 340, 72, 120, 4,550.
No.
No,
No. Well, you missed this one.
what, the 15?
The
120?
The 120?
Oh,
Okay. Then the next one. Okay.
yeah, 400.
And what was it?
6, 8,
4,000.
550. And
And
then
last term.
170.
170.
Second one.
When you add them all up, what do you get?
Oh, that part.
Important. So everybody see, all right, multiply each individual x and y paired score with each other. That's what the x and y means. Takes x, y, multiply together. You're gonna need the sum of all those paired terms squared. All those paired terms times each other.
9,692. 9692. Cool.
All right, so that's the full table you're gonna need.
Let me fix the formulas before you move on.
Now this is.
So is this what we're gonna have, did we need this whole table for our assignment?
You're gonna need this whole table, once you calculate the values, in order to calculate the slope, right?
That's just one part.
That's just the first part.
That's not gonna be on our assignment already, we have to write that down?
That will be on the homework later tonight, yes.
Oh, okay, just one. Okay, let me write this down first.
You won't have as many numbers, because I have 13 people in the class, and I don't need 13 numbers. In the
Oh.
class. So
Or
we're
on
gonna
the
get like 5 or
exam.
6, but the math works the same way in terms of
Okay, let me make
multiply together and getting column. It may not be columns, it may be rows. So I might have, for example, a series of x scores like this, a series of y scores like this. a series
Honey,
of
something
x
just
squared.
happened, because I'm literally, my formula doesn't look like yours.
Which one? This one?
Oh yeah, you changed it.
I
What?
changed it slightly.
You had it wrong.
I changed it slightly.
You're fine.
You did say that.
I changed it a
I'm
minute.
so confused right now.
That's
Oh,
okay.
he had messed up the
He
formula.
had the
Oh,
formula
okay,
wrong.
so,
I
So
had the
change
wrong
it, so
formula
fix
wrong.
it, fix
okay,
it.
so I need to take,
Change what you had earlier to this one.
Yeah. She's like, my formula, I was like.
I'm like, hold up, yeah.
That's funny.
Okay, so B, X,
I love
N, E, X, Q, okay, so then that's a double, okay, so there's where I'm wrong, I think, too. E, X,
Not me.
okay,
Super.
sign, well, yeah,
Thank you.
okay, but I'm missing oh, there it is, got it.
Alright.
Okay, so let me make
What?
sure I go through this.
Once you have your full table over here, right?
Okay.
This is all the input values, primarily here at the bottom. These summation terms are what you're gonna plug into the formula
Right.
to calculate terms you need for later.
Okay,
Here.
so 234 or 239,
This is 239,
294,
294,
9161,
9161.
oh, 9161, I got 9181.
Are we at 9161?
Yeah, 9161.
Okay, so 9161, and then
10,608,
okay,
and then 9692.
Mm-hmm.
oh, I need to rewrite all this.
Alright? So now you start plugging in things in the equation. But like I said earlier, you may see them in rows like this. You have your summation over here, your summation over line. But it doesn't matter whether it goes across or down. What you want are the sum terms for each of those set of scores. So, at this point, it's just plugging in values,
Right.
right? So I'm gonna redraw this equation, just putting in kind of the outline of it.
So E equals
What's n?
1, 2,
Sure.
3, 4, 5, 6, 7, 8, 9, 10.
Is n 12 or is n 24?
What?
Ooh, that's a good question.
It is a good question. I'm glad I asked.
Why
I
would it
really
be?
don't know.
It would be. It would if we're using both x and y. Wouldn't it be 24? Because there's two
That's
values.
the question I'm asking.
Okay.
I say yes.
I said 12.
I say.
Okay.
Why do you say 12?
I don't know.
Because he wanted to be different.
Yeah, I get it. No, that's
Is
what I
it
said.
because
That's what I
it's
said at first.
True,
I'm just
true,
saying.
true.
Is it because of the number of? We're just.
N is
Doing
typically
eight.
the number of scores.
Well, there's only 12
Right.
points though.
There are 12 points.
Ah.
N in this context is the number of paired scores.
Say less.
So each x, y, that's 1 point. That is
Together.
1 data point, right? So N here is the number of data points. N here is 12.
You know, I was just playing right.
But the reason I asked that is to emphasize this point, right? Sometimes on the exams, on the homework, people say, oh, well, there's 12 x scores, there's 12 y scores, and they jump to 24. That will get you the wrong answer.
Right.
Right, that's a common mistake, which is why I pointed it out. But 12 is the correct answer, right? Now you're simply plugging in other values. So, let's start here, Mackenzie. What value do I want to plug in the top left of my numerator for a summation of x, y? Is Everybody see where we got that value?
Yes.
Pull it straight off right here. Right? What value do I need in the top of the denominator, top of the numerator for the numerator?
239 and we made it to both.
Yeah, do both.
294.
Does it matter if I go 239 times 294 or 294 times 239?
Doesn't matter.
Does not matter because you're multiplying. It's commutative. Right? The order there does not make any
Is that
difference.
4,900
Where?
on the third row down?
Here?
Yeah, right,
That's a 49, yeah.
4,900. I just wanna make sure all my numbers match.
Because that is 70 squared,
Okay, gotcha.
right? All right. So what's my summation of x, Jacob?
239.
Try again. Summation of x. I should have said better. Summation of x squared in the denominator.
Oh,
I'm looking for
9161.
this value,
9161.
right? Which is a 9161. Now I want summation of x. Right? It's going to be squared because it's quantity squared here.
Right.
But summation of x plugs in by itself. Dina, what value here?
239.
Right. Notice squared. Right. Do not, for example, square the 9161. Right. This value is already the summation of x squared. That's already implicit in it.
Right.
This value is the one that has to be squared in the equation. Right? Don't plug in the same value for both and square both. Sometimes you'll put in the 236 squared, 236 squared, plug same number both. These are two different numbers. Summation of x squared is different from summation of x quantity squared. Does that make sense?
Nope. Not yet.
That's the question.
Almost.
Can you see the top part of the equation? That's just all the letters plugging in?
Well, I'm just a few seconds behind. So
Every
I
one of
rewrote
those
my stuff to
quantities-
make sure.
Every one of those quantities shows up in that equation.
Okay, yeah, it's gonna make sense. I just gotta make sure my stuff is right. Is that nine, at the bottom, 9161?
That's 9161.
Okay, got you.
I thought it was 239.
It's 234 is the summation of x.
So
This
why
is
is-
9161, the summation of x squared.
So why is that 239?
Because it comes from here.
It looks like a 9 over there.
It is a 9.
I thought that was 234 though.
No, it's 239. There's a 294.
No, I meant for the
This value is
summation of x.
239. That's a 239. That's a 9. May look bad, but that's a 9.
Okay, got you. E, or, okay, there, square, 10.
Which number in the table did I not use in this formula?
Y squared?
Summation of y squared, right? In other words, I got a column here. That number doesn't show up over there. Okay? That is okay for this version of the problem. There are other versions of problems, they'll be coming up, that will use it. We'll use the summation of y squared, but not in this one case. All right? So you're still going to want it over here in the table, even though it does not show up directly in the formula. All right? So there'll be other formulas later on where it will show up. All right? So you're going to want the data to begin with. Does that make sense? At this point, this is simply plugging into math. Right? So you got the 9, 6, 9, 2. Everybody done the equation here? I would need to calculate for it. I'm not doing it in my head.
It's 70266 over 12.
7, 0, 2, 6. Oh, 6. Do I get that? That makes sense. And then 9, 1, 6, 1. You get 239 squared.
57121. Yep.
The answer's gonna be negative, but I know you're gonna say something about that.
No? Is it?
No, it's not.
Well, when you divide, what do you get when you divide the 70,000 by the 12?
266 divided by 12, that's gonna give you
Five.
5,855.5,
Okay. So that's not going to be negative. That's going to be positive. Then.
right? Divided by 12.
No, that's not divided. That's already divided by the 12. Divided by 12 is the 5,855.
Okay, cool.
Right? The bottom here is going to be the 9,161 57 divided by 12,
4760.08.
4760.
.08.
I'll tell you what, I'm just gonna round it off, because given these big numbers, the .08 is not gonna make any difference.
Okay.
So we'll round it off to 60,
My darn calculator.
which is gonna give us, what's the numerator and denominator?
Wait,
Subtract out.
the denominator is 4400.92. Well, actually, don't take my answer because I kept the 08.
That's okay. It won't be 4400, it'll be 4401, right? That looks strange, shouldn't be 44.
We left the decimals on there. So
Yeah,
it's
decimals,
0.92.
I'm not on the decimals. Well, that's why, okay,
Why?
nothing. In my own head, I'm explaining my own thoughts. So what's the numerator?
3836.5.
3836.5. Okay. And if you divide those, it's
0.87.
60. So you get a .87. Right, so a question comes up. You actually asked a question a minute ago. It didn't actually happen, but it may actually happen in the future. Can you have a negative number over there?
Yes. Right? You can have a negative slope.
Sure, you can have a negative slope.
But what?
If you are going to have a negative slope, and you're correct, you can definitely have a negative slope. What would that mean?
It's the opposite way. It's going
Instead of going up to the right,
It's going down.
the slope will go down to the left in some way, right? That is entirely possible.
Okay.
If you are going to have a negative slope, where must the negative occur in this equation?
Ooh, I don't know.
Well, let's start. Would it occur in the numerator or the denominator?
The denominator?
Numerator.
Yes!
Numerator. I would say numerator.
Yeah, it doesn't.
No.
It doesn't,
Long.
If it were both, it would be positive, right?
it doesn't matter.
Oh,
It doesn't
like, can
matter.
it be either?
It does matter,
Does it?
right? And it cannot occur in the numerator. It cannot occur in the denominator. So
Because.
it must occur in the numerator. Because this part of the equation
Uh-huh.
is called the sum of squares. Go back a second.
Yep, I already know what you're about to say.
Can that equation be negative?
Yes.
Yep.
No, you can't take a square root of a negative.
You can't.
Okay,
You
gotcha.
can, but not in this class.
Yeah.
No.
More correctly, a standard deviation can never be negative.
Okay, yeah.
Right? A standard deviation must always be positive.
Oh,
And the
okay.
reason the standard deviation must always be positive is because this value must always be positive.
Okay.
And this value is always going to be greater than 0, right?
Mhm.
This value must always be positive, which means this value must always be positive.
Okay.
Because that's the
It's the
exact
same.
same piece of
It's the
equation
same.
there. If there is going to be a negative in your slope, the negative must occur here. In other words, this value, when you divide by the 12 and divide by n here, in the numerator, can be bigger than the summation of xy. Right? But this value on the right here in the denominator cannot be bigger than this one. Right?
Okay.
Because the denominator must always be positive. Right? You can have a negative slope. Right?
Are we gonna be graphing these?
No.
Oh, praise God.
No, you're not gonna grab these. This is mostly kind of conceptual.
Okay, thank God.
Alright, so we have 0.87 for our slope. Pulling that back around here with this for a second. Here's my 0.87, B for slope. Okay?
So would that be like a question on the test, find the slope for this second
Sure.
thing? Okay.
That'll be the actually, the question will probably, it'll be a question on the homework. Right?
Okay.
Calculate the slope. Question on the test will be calculate the line of best fit.
Okay. And you'll need to get that.
You will need to start with the slope.
Okay.
When you're calculating a line of best fit, always start the calculation with calculation of slope as we've done it here. We're gonna take a break in a few minutes. If you want to go, you can.
Oh,
I don't know how much emergency it is.
No, she has to go potty.
The equation for the line looks like that. As any equation for a line would look like. Two variables, two constants, one's multiplied, one's added. Now, I can plug in the 0.87, so I get y equals 0.87x, right? Plus a, where I just plugged in the 0.87 there, okay? I need now to calculate an intercept term, which is the a term, right? If you might remember from your, let's say, earlier high school career, what do you plug in for x and y in order to solve for a?
X and Y.
Which x and y? A bunch of x's and y's.
Oh, does it matter?
Oh, yes, it matters.
I didn't know
Oh,
that.
yes, it matters.
So would it be the regular?
If every single paired set of scores fell exactly on a straight line,
God,
then it wouldn't
yeah.
matter.
Okay.
But these scores are all over the place,
Right.
right?
So it matters.
So now it matters, right?
Hmm.
The question becomes, what is the most representative pair of x and y scores?
The most representative would be. Okay, so what does that mean? I'm sorry. Let's figure out what that means.
Big picture, I got a bunch of paired scores.
Right. The most.
Right.
So you would take the most.
If let's
right?
say this one down here is the 3, 5,
Right.
right? These two scores here, right?
Right.
And let's say the one way up here is the 40, 45.
Uh-huh.
So the one in the middle. No.
Right, well, close.
The average.
There you go.
Aha. So
Right.
you would take.
The one in the middle.
But there is no paired score in the middle.
Yeah. So we add them all up and then divide them by 12. Both.
There you go.
Okay. Whew.
What do you add up?
All the
X
things.
plus Y.
So you
Yeah.
take
That's
the
good.
Hang on,
and
slow
you
down.
divide it by X.
You take
You
your
are
summation
correct.
of X
Okay.
divided by 12.
You want the most representative paired set of scores. Given these scores are paired sets of scores that are variable and all over the place, right? You want the best representative of x and the best representative of y. The single score that is most representative of each of those is the mean,
Right.
right? So you want the sum of x divided by 12 and the sum of y divided by 12. That gives you a paired set of scores. That score, by definition, is going to be the score that falls exactly in the center of that line,
Okay.
Okay.
right? So I take the 239, divide that by 12, and I'll probably get something like
19.92.
999. Say 19.9. Does that work?
Yep. Sure.
Notice in this case, I'm going to say x bar is 19.9.
Because
If
that's
I
the
do
mean.
294, right? That's going to give me a value just a hair under 25.
24.5.
So X. The mean.
So now I got a mean for x and a mean for y. Does everybody see where I got those two terms?
Yes.
I took the sum over here, divided by the total number of scores, which is 12 in this case. Got a mean. Because these are sample sets of data, x bar, y bar. Right? We'll go to my equation. The most representative pair of scores is now x bar and y bar. I plug in those values. Y bar gives me the 24.5 times 0.87 times 19.9. I solve for a.
But does it really matter if we like have the bar over it? Like if we write that formula down on the test and it doesn't, if they don't have the bars over it, but we give you the right answers with the summation?
These are technically different equations. They
Okay.
both represent lines, right? When you are plugging in the means, you're plugging in specific numbers, right, for calculational purposes. You probably should have the bars there, but if you do it correctly on the page, you get the final number and you plug it in. I'm not going to quibble over if you didn't put the bars over or not. As long as you if you know what you're doing well enough at that point to get the right answer,
Okay.
I'll be able to interpret that.
Okay.
Is that all right? Yep.
I like this better than bell curves. I can understand numbers. I hate art. If that means anything.
Have we got a value for a yet?
7.187.
Now I go back to my generic form of a line,
Okay.
which any old y equals 0.87 times any old x plus 7.187.
That's our line.
And that is our line of best fit.
Oh my goodness. Beautiful. Yeah, I think I do like this better.
Go back a little bit. You did the 0.87 times 19.9, right?
Correct.
0.87 times.
Take that total, subtract it from both sides,
Take that total. Okay.
all right? And that will give you a on the right, 7.1 on the left.
Yep.
You can actually solve for a first, and then plug your numbers in. You could rewrite this exact, you can rewrite the equation as A equals y bar minus b x bar. And the text will have that equation as well. But that's just solving algebraically first and then plugging the numbers in. So you plug in the 24.5 minus 0.87 times 19.9. You still get the exact same value. Here, I like personally plugging in the values and then solving for it. But some people like rearranging the equation first and then plugging in the values. Either way works. I don't care. Does that make sense?
Yes, it does.
Doing a little bit of work by ourselves, though, will help you. Homework.
Next question. Right? Suppose you find somebody who drives 50 miles to get here. What's your best prediction of how long it should take them to get here?
50 minutes or an hour.
See, you're on this. Got it.
I
Right?
think I do. I told you I like this better than the last one.
Assume you find a person who drives 50 miles to get here. What is your estimated time for them to take to arrive here? In other words, given, we'll say, given x equals 50, what is y? That's 50, not 56. How do you get that? Caitlin, how would you get y here? You know x is equal to 50. You got this equation here, right? If I plug in the 50, solve for y. Right? Say again.
It's 50.69. This one's 50.687.
It seems like it's close.
That's right.
I guess 51 minutes.
50, well, go ahead and use 2 decimal places. 50 what?
50.687.
We'll say 69. So 50.69 minutes. Does that make sense?
What was the question so that I can,
The question was, assume this data is representative of population data. What is your best prediction of how long it will take someone to get here if they have to drive 50 minutes, if they have to drive 50 miles?
okay, and so you would do the 87 times 50 plus the
27 times 50
Okay.
plus 7.87. And that gives you value for y.
Right.
Does that make sense?
It does. Thank you.
Exactly.
So what's your best prediction for somebody? Let's take it over here. What's your best prediction for somebody who has to drive 3 miles to get here?
I got
9.797.
9.797.
See, but,
Take it to the bank.
What is it, 9.797?
Yeah.
Yes.
but why wouldn't it be 5? Because there
That is
a
exactly a
point.
very good question. That's why I did that number,
Okay.
right? That's a good question. Everybody see the question she's asking? It's an important question. In my original data, I've got a 3 here for x.
Uh-huh.
Why not just simply say 5?
Because it's not the average time.
Because
right?
this 5 and this 3 are not necessarily on that line,
True.
right? All these paired sets of points are scattered around.
Okay.
That does not mean they fall exactly on the line. If the 3 and the 5 as a paired set of data fell on the line, it would be perfect prediction.
Okay.
The line is a line of best fit, which assumes close. You may get a prediction which is different from the raw data because the raw data is not on the straight line.
But it should be somewhere close.
You're probably reasonably close,
Not
right? No, it's not like 70 over here,
Right.
Yeah.
right? You know, the reason it's 9 is because this intercept was a 7, right? That's why it's far and above. The closer you are to the mean, right? And notice the 50, about double the mean. Right? The closer you are to the mean, the closer those values will come together, right? Because that's where the line's going to be in the center of the data. The more you get to the extremes of the data, the more variability you'll have. Typically. Not always, but typically. Does that make sense? All right, so take a break in a second. Let me ask another question. Let's consider the question, right? Assume this data is representative of the population as a whole. Right? If it takes somebody 30 minutes to get here, what's your best prediction of how long they have to drive? Or how many miles they have to drive?
So now we don't have X and we have Y.
40.
Now, giving you a Y score, ask you to find X, what do?
Plug in. Right?
What?
We
For
plug,
Y.
we plug,
So you plug in a value of 30 or so here,
Yes.
calculate solve for X.
Yes.
that'd be.
You might think that's the way it works, but that's wrong.
What?
No, cause you said at the beginning that it doesn't matter what
You're joking.
it
No,
doesn't
I'm not
matter
joking.
what each of the lyrics represent, it would be, they can be X or Y or whatever, right?
The exact designation of the variables doesn't matter. Right. The equation for the line that's used to calculate it. This is a line of best fit predicting minutes from miles, right? If I wanted to predict miles from minutes, right?
Whole new formula, huh?
Yes and no. Here you have a little X there. This is going to be the slope predicting X from Y. This is the intercept, sorry, this is the X-intercept, right? The equation for the slope, so this B sub X, this is the B sub Y we used to use. Equation for the slope, numerator. I'm going to clean that up, that's sloppy. What's the difference between this slope equation and this slope equation?
There. Nothing.
Yes, there is.
So you're using the summation of y squared.
Oh. Got me there.
And that will give you a different value,
That is crazy.
right?
Okay.
We're not going to do that equation in the interest of time.
Ooh.
I'm not going to have you calculate that equation
So
on the
you
exam.
write-
I want you to be aware of it. Well, we don't have time to miss 2 days. Normally, I would do both equations, both
Yeah.
things.
But don't even worry about it.
We worry about it.
Conceptually, I want you to be aware of.
To know that that's how you do it.
For example, potentially, I may ask you as a multiple choice question.
Okay.
Okay.
That's right.
Okay.
I want you to be aware of the fact when you're calculating a line of best fit, right? Most people will calculate essentially the line which predicts Y from X. But you have to recalculate it because it's a different slope, it's a different X-intercept instead of a Y-intercept, if you want to predict X from Y.
And we'll need to know that formula for the multiple choice.
I'm not gonna give you that formula multiple choice. I'm probably not even gonna give you that formula on the formula page to confuse you. I want you to be aware it exists as a separate formula.
Okay.
There is one point, and your text does have this discussion, there is one paired set of scores which will be identical regardless of which way you're trying to predict the values. So for example, let's do it this way. How many minutes will it take you to drive 19.9 miles? Do the calculation from the equation right here. We just have to calculate this equation right here, right? I gave you miles, 19.9. How many minutes? You all do it the long way.
24.5.
Wait. There's a faster way.
But I don't know.
What's
I
the
don't
faster
remember.
way?
I don't remember where that 24.5 was.
Yes, you do.
Ah. Yes, I did.
The mean must fall at the center of the data. The mean predicts the mean, right? If I give you 19.9 miles, it predicts 24.5 minutes.
Okay.
Conversely, regardless of what I have up here, if I ask how many miles did you drive, if it took you 24.5 minutes, you tell me 19.9 miles.
Wow.
Because that one point, that one paired set of scores is used to calculate both lines.
And that's on the line.
Yes, that point that point is by definition on the line. It's
Okay.
on both lines, it's the center of both lines,
Okay.
Sounds great.
right? That's when both lines actually cross if you graph them both simultaneously.
Okay.
You gonna do another one of these after the break?
Yeah, we do an electric break, that'll work. Does that make sense?
I'm getting it though. I'm definitely getting it.
Bless you.
Wait.
Alright, so take a break. Come back in, we'll do a couple more linear regressions, and then I'm gonna do correlation coefficients, which is gonna be an extension of this.
Alright.
The formula's gonna be more involved, but very similar.